Hi guys, welcome to Esoteric Tech. I want to thank you for tuning in. In this video, I'll be continuing with the Golang series. If you've been following along with the interface series, I know I have one more final video to do, but don't worry, I'm going to do that. I just didn't want to leave all the other people hanging. So the focus of this tutorial will be on arrays and slices. By the end of this video, you'll have an understanding of what an array and slice is and how to use them in Go. I'll start off by explaining what they are. I'll show you the syntax of an array and slice. I'll provide you with some examples in code of how to use them. And then I'll also show you guys how to manipulate them. As always, I want to say that if you guys find this tutorial to be useful, please do subscribe. Those subscriptions and likes are the feedback I need to know if this content is actually helping you guys out or not. So let's go ahead and get started. First of all, I want to say that Go handles arrays slightly different than other programming languages. So even if you have experience with programming, it's worth watching this video. But let's move on to the definition. An array and a slice is essentially a list of items that are all the same type. So if you have an array or slice of integers, then every item in the list must be an integer. If you have an array or slice of strings, every item must be a string. In addition, each item is numbered or indexed. So Go, like other languages, uses what's called a zero-based index. The first item is always 0, and that really refers to the position of the item. So we always start at 0, and we work our way up from there. And this applies to both arrays and slices. Now, if you're completely new to Go, a lot of what I'm about to explain might not make sense. But I want to say it's really important to watch this because this is one of those topics that as you become more familiar with the language, eventually it will click and you'll understand the value of what I'm saying. So just follow along, and I promise if you stick with it, eventually it'll make sense. You really won't be working with arrays too much in Go, or I shouldn't say too much comparatively. Typically, you're working with slices way more than arrays. But these two data types are connected to each other. So it's important to know and understand an array in order to understand what's fully happening when you create a slice. As I mentioned, an array is a numbered list of a single type, but it has a fixed length. That means once you create it, you can't change the amount of items that can be placed in it. So if you want to add to an array, you would actually have to create an entirely new array and then copy over the items of the original array. A slice, on the other hand, is similar, but it's much more flexible. You can actually change and resize the length of the slice. So if you need to add an item, you can simply append an item to the list. If you need to reduce the size of a list, you can actually take a slice of a slice. One important piece or information about a slice is that a slice is built on top of an array. So whenever you create a slice in memory, you're actually creating what's called a backing array. And the array is what contains the actual data. And the slice just contains a reference to the data and the underlying array. For this reason, a slice is known as a reference type. Now, I covered reference types in an earlier video when discussing pointers. So if that term is foreign to you, I encourage you to take a look at that video. But one way to look at a slice is to consider it as a representation of the array that actually gets stored in memory. You can, of course, still access the data from within that slice, but it's just important to know that when you change that data, you're really changing the data in the array. So a slice is a reference. It's a reference to a contiguous portion of the underlying array. And when you create it, there are these hidden properties of a slice that get created along with it. And these are the properties here. You've got a property that defines the underlying array. You've got a property that points to the starting point of the slice in the array. So in this situation, you can see we've got that first position of the slice pointing to position number, it's 3, it's actually position 4, but it's index 3. And so that's the starting point of the slice and the array. You've got a property that defines the length of the slice and a property that defines the capacity of the slice. And that's an optional value. And I'll show you guys what I mean with that. So I think that's enough theory for now. Let's go ahead and hop over to the code and I'll show you guys how to work with it. The first thing I'd like to show you guys is how you create a slice. And there's a couple ways you can do this. As I've indicated in the comments below, one way you can create a slice is by using Go's built-in make function. The make function accepts 3 parameters. The first one is the type. That refers to the type of data that you'll be storing in the slice. The second parameter is length, and the third is capacity. Now, it may be confusing as to what those two actually mean, but keep in mind whenever you create a slice, it creates an underlying array in memory. The capacity refers to the maximum amount of items that can be stored in the underlying array. The length is the actual length of the slice. So it's not possible for us to create a slice that exceeds the amount of items in the underlying array. That's why we have a separate value. Capacity is the number of items in the array. Length is the total number of items in the slice. If we were to go ahead and do this in code, it would look something like this. So what I've done is create a slice that holds a type of string. So the syntax for that is always to use 2 square brackets followed by the data type. The length of the slice is 3 and the capacity is 8. I then use 2 of Go's other built-in functions, the len and the cap function, to print out the length and capacity of the slice. Now there are a couple things to take note of when using the make function. The first one is that you don't actually have to declare the capacity of the underlying array. Technically, you can declare the length only and the capacity will be assigned the same value by default. So for example, if I was to remove this 8 here and then run this program again, we see now that the capacity is automatically set to 3. The second thing to be aware of is that when you use the make function, you're not actually setting any values in the slice or underlying array. The values are actually set to the default 0 type of whatever data type you're storing in the slice itself. So in this case, we're creating a slice of empty strings, and that's because an empty string is the default 0 type of the string data type. Just to make sure you're following me, I'll go ahead and actually print out that slice. And we can see here that it just prints 3 empty strings. Now it is possible to actually create the slice and set the values all at the same time, and that brings us to the second way that you can declare and initialize a slice. So I'll comment this out here. And the second way is to actually just use the square brackets, as I mentioned earlier, followed by the data type. And then in curly braces, you just include the items that you want to insert into your slice. So now I created a slice of type string and added these 3 items. The length is automatically set to 3 and the capacity is set to 3. And let's run that just to make sure. Let's do another example, but with integers this time. What I've done now is create a slice of integers instead of strings. So I've changed the syntax and used int instead of string, and I've inserted numbers into the slice. And we can also print out the values of this slice just like we did with the string. It's also possible to print out individual values of the slice by referring to the specific indices. So for example, the way you do this is use the name of your slice, and then within square brackets, you put the name or the value of the index that you want to print out. So I'll put 1 here and run this. Now hopefully you weren't surprised at the fact that we got 2 instead of 1. Remember that I said slices are 0 base index. So that means this is actually position 0 and this is position 1. So that's why we got that. It's also possible to print out multiple values, and we can do that by specifying the beginning value, and then we can separate that with the colon and add another value. So for example, if I include 4 here, what I'm saying is I want to print out all values starting at index 1 up to, but not including, index 4. So that would mean that I'm starting out with 2. This is index 2 right here. So this is index 1. This is index 2. This is index 3. And 5 is index 4, but it doesn't include that. It's up to and not including. So if I run this, we see that we get indices 1, 2, and 3. And if we wanted to, we could create an entirely new slice using that same syntax. So what I'll do is copy that, and I'll create new slice. Set that equal to this here. Sort of copy. Let me do that again. Copy. And then I'll print out the new slice here. You can see it prints out the same thing. Now when using this syntax here, it's also possible to omit the index before or after the colon. So for example here, I can delete that and leave it just like this. And by default, it automatically means that this would be like a 0 position. So it'll capture all values starting at the beginning of the slice up to, but not including, index 4. And I could also do it like this, and that means to the end of the slice. So if I run this here, so in this first situation, we've printed out from index 0 up to, but not including, index 4. And here we've printed out index 1 all the way to the end of the slice. You can also change the value of one of the items using square bracket syntax. So if I wanted to, for example, change the value of the first item, I could do something like this. For my slice, index 0 is equal to some integer. And we can see that that changed the first value of the slice. And just to illustrate a point I made earlier, let's change this to 2 and then run that. So now you can see that this value, this index 2, has been set to 32 in both of these slices. And that's because each of these slices still share the same underlying array, their reference type. So all I did was copy the reference of that underlying array. The next thing I'll show you guys is how to use the append function. Now remember I said one of the benefits of using a slice versus an array is that you can append any amount of items to a slice that you want. But with an array, you're not allowed to exceed its capacity. The append function takes 2 parameters, the name of the slice and the value you want to append. So if I wanted to append an additional value to my slice, I would set it equal to the append function, which takes in my slice and adds the value 8, and append always appends it to the end of the slice. And I actually need to get rid of this colon because I'm not creating a new variable. And I'll run this. We can see here that we've appended this value of 8. Now one thing you also may have noticed here is that the capacity is now set to 14. This goes back to what I said earlier about the importance of understanding what's happening in the underlying array. Let's step away from the code here because I really want to show you guys what's happening. So hopefully by this point you guys understand that if you were to create a slice like this and initialize it with 4 values, what you're essentially doing is creating a slice with a length of 4 and an underlying array also with a capacity of 4. The capacity is just the default value because we didn't declare it with the make function. What I just showed you guys is that you can use the append function to add an additional item into the slice. But I also said earlier that you can never extend the length of the slice past the capacity of the underlying array. So for example, if we were to use the append function and add the value 5 on the end of the slice, what happens to the array? Well, when we do that, it actually gets rid of the initial slice, and it replaces it with an array that is double the size of the original. So the length of the slice changes to 5, and the capacity of the slice changes to 8. So just to reiterate, every time you add an item to a slice that exceeds the capacity of the underlying array, it doubles the capacity of the underlying array by replacing it with a new array altogether. I'll give you guys a prime example of why knowing what happens in the underlying array is really important. In one of my roles as a back-end developer, I was on a team and we had written some back-end code so that values could be dynamically added to a slice. So these values were being added at runtime, and we didn't know the total amount of values that would be inserted into that slice. It ended up being thousands. And what we found was that we were consistently running into memory issues in our environment. And this was partly caused by two things that I've showed you today. One is that we weren't using the make function. Two was the built-in behavior for the array's capacity to double every time the length exceeds it. So each time the length of the slice exceeds the capacity, it doubles. So let's take this example here. Let's say that my computer memory was only capable of holding 12 values in my array. If I was to continue to append items to this slice here, once I got to the 9th item, the capacity of this underlying array would end up being 16. At this point, if my computer is only capable of holding an array with 12 values, I've already exceeded that limit. But what if we use the make function to declare the capacity beforehand, and then we wouldn't have to worry about it doubling past our limit? So if we defined our slice like this, we've already set the capacity of our array at 12. That means we will never exceed it by adding any items, because we only need to add 9 to our slice. So the capacity of the array stays at 12 because we never exceed it. Now, I'm not using this point to say that you should always use the make function. All I'm saying is it's important to be aware of what's happening in the underlying array. The last thing I'll show you guys very quickly is how to range through a slice and how to append one slice to another. So in terms of ranging or looping through a slice, if you're already familiar with for loops, this is nothing new. Basically, the syntax goes like this: for index, comma, value in the range of my slice. So here, I've actually got just an underline. So that means I'm actually not going to use this index, but I represents the value. So I'm saying for index, comma, value in range my slice, print out I, which is the value. And so I've actually already printed that out here to the side, but let me go ahead and clear that and I'll run that again. And so we can see that we print out every single value as we loop through that slice. The second thing that I said I'll show you guys is how you can append one slice to another. So here, if I uncomment this, comment this out, we've created a new slice and it has just 3 integers into it. This is the syntax if I want to append this new slice onto my slice. And what you do is you pass in the original slice that you will be appending to, followed by the slice to be appended, and then you use these 3 periods, which is also known as ellipses. And after you do that, the result will be a slice where this one has been appended to the first parameter. So I will run this, and we can see here that we've appended those 3 values to the end. So that does it for this tutorial on arrays and slices. This is probably one of the longer tutorials that I've done, but I think everything that we went through was very important. So I encourage you to practice with these on your own. Ask me any questions in the comments if you guys have any, or if something was unclear. I'll follow up with the next tutorial in the interface series Otherwise, thank you guys for watching. I appreciate it. Subscribe, as I've mentioned before. I'll see you guys on the next tutorial on esoteric tech. Thanks.